The following is for 2008 Math 125 Department Final. In this video, I will do number 4 and number 5. Number 4. Radioactive carbon C14 has a half-life of 5,730 years. After 1,000 years, 3 grams remaining. What was the initial quantity of C14? And round your answer to 2 decimal places. Now, before we start, we take a look at the answers. A lot of the answers actually close to the numbers pretty close, like 3.39 and 3.30, 3.16, 3.52. Okay. Now, so what I'm trying to say is this: with these numbers very close to each other, we will avoid rounding too early. Okay. Definitely we will use calculator, but we will not round the answers we have. Okay, if you round it, then make sure that you make it into a lot of decimal places until your final answer. Okay, now to answer this question, I will do it with 2 different ways. First one with textbook method, and from that textbook method you will see that there are something that we can memorize, and that will be quite helpful. Okay, the first method is using textbook method. Now, textbook method, you definitely need to memorize a formula of exponential decay. The amount after time t is equals to the original amount or initial quantity times e to the power of negative kt. Now, from the given information, the half-life is 5,730 years, which means after 5,730 years, the amount will be half time the original one. Okay, this is negative 5,730 K. I will cancel the N out, the initial amount. Then I get 1/2 equals to e to the power of negative 5,730 K. Okay, then I apply natural log to both sides. Basically, I rewrite this into logarithmic form, negative 5,730 K, and this is negative ln2, and I will cancel the negative after this and divide by 5,730. K equals to ln2 over 5,730. This is the K. Okay, now from here, then I will plug into the formula again. After 1,000 years, so A1000, let me point at that formula. This is what I'm doing. A1000 e to initial amount times e to the power of negative k, which is ln2 over 5,730 times the time. That time is 1,000. Okay, now you may say that you can count this first, but we hold back a little bit. This is 3.00 equals to initial amount times e to the negative 1,000 ln2 over 5,730. Now, what I'll do is I will move this, I will diff this, and I move it to the other side. Basically, what happens is this. This will be 3.00 times e to the positive 1,000 ln2 over 5,030 equals to initial amount. Okay, notice that I divide by both sides, becomes a positive exponent on the other side. Now this is the point where you will use calculator. Now take a look on the way I compute it. Calculator. I will first compute 1,000 times ln2 and divide that by 5030. Now then the exponent of that answer. So you see, by doing so I keep the memory. Okay, the glare. Okay, I think this one is better. Use the memory without doing any rounding. Okay, so what we have right now here is for this e to some power here, whatever the answer there, 3, I get 0.38 dot dot dot, which if I round to 2 decimal to 3.39. Okay, and we will see the answer is A. Now notice that it takes me a bit longer to do this problem for first one because I need to memorize the I need to do this, which will be easier if you can memorize the okay. So this method I will do is doing formula method, memorizing. For if half time is call that T naught, then the K will be ln2 over T naught. Okay, if you can memorize this form, be better. Okay, now and then this is the number to the big formula at equal to a naught times to the negative k t. Okay, now so the k ln2 equals to ln2 over 570, and then 1000, the amount after 1000 0 equals to the initial amount times e to the if ln2 is 1000 over 570. Now from here this will be in way 3.00 e to the 2 times 1000 over 5070. Okay, 3.385 dot 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 again. I round to 3.9. That's one. I think another thing that some kind of special form reference, but some teachers in particular I will teach in class. This will be okay. Now this is this for half time. Formula for half time is the amount at times the original amount times 2 to the power of t per 5000 in this case. Maybe let me erase this first before I go there. I want to say that T naught time for that. Okay, now we have exponential growth. This is exponential, right? Life for exponential growth, this will be instead of negative exponent like this. So if you have growth a double time, you can use this formula. Half time, I will use this formula. Okay, this is a lot faster. Okay, a lot faster because then I can just plug it in. This is 1000 equals original amount times 2 power of negative 1000 over half 5720. Okay, now this is 3 equals to a to the power of negative 1000 over 5720. Then from here, the other side, 3.00 times 2 to the power of 1000 over 5007. Use your calculator. Let me do it here. Okay, 1000 over 5070. That's the number. We'll take 2 power that answer and then multiply. Okay, get the same answer, right? 3.885 dot equals to a naught. That's 3 point. If I round to 2 decimal places. Okay, explanation here is long because this can be done a lot easier if you do it memorizing the more advanced one. Remember, formula here is for exponential decay. If not exponential growth, this is a positive. Now this formula is especially for if the half-life or doubling time. Okay. Part 2 here is if you can memorize this formula to get the A, it will be a lot faster. So you save time in doing this. You don't need to show the work here. Okay. The step after that is basically the same. Number 1, the first way is the standard way of doing it. Textbook way, I call that. Now let's go on to number 5. Square formula to solve this equation. Now, to be honest with you, they tell you quadratic formula to hopefully to make it easy for you. But the question is supposed to be just to solve this equation, and you are going to figure out which way to do it better. Okay. Now I will show you first the quadratic formula. The A here is 12, B here is -12, and the C is 3. As usual, we will first compute the decrement, which is b squared minus 4ac. That's -12 quantity squared minus 4 times a times c. And we will see this is 144 minus 134. That's equals to 0. Okay. Now, I hope in that class you learned something important about the discriminant. If the discriminant is a perfect square, then the equation is actually factorable. Okay. Now here is even more, because the discriminant, then the should be only one solution, one unique solution. Okay. Now let's proceed. X1, 2. This is a standard way of doing apply under the discriminant first and then applying the numbers. It's negative b plus minus square root of the discriminant, or 2 times a. 12 plus minus 0, which is 12 over 24. That's half. Okay, this way I see the answer is C. Okay. Now that's the quadratic formula method. But again, let me say, if you ask me to do this problem, what I'll do, I think we'll follow doing quadratic formula, but doing the discriminant first. Once you get discriminant so apply it in, maybe it's easier. Okay, that's first. I want to show you that this is actually factorable. In other words, this is a question that I can give to Math 115 students and they still do it well here. Okay, now, let me start. I will use factoring. If you don't see anything, any method, then start thinking, doing it by factoring. Factorize the 3 out, the common factor. And then from there, I factorize this 4x squared minus 4x plus 1. You will see that 2x minus 1, 2x minus 1. And then from here, I see that x equals to 1/2 both of them. Okay, so that's give you C. 5 which we don't really like to be, is this 3 times 4x squared minus 4x plus 1 equals 0, factor the 3, and then divide by 3 both sides, again 4 minus 4x plus 1 equals to 0, and then from here we have to be completed square. This is 2x minus 1 squared. Now we see that 2x minus 1 equals to 0, therefore x equals to 1 half. Okay. But this step 3 here is not really a common way to do a form of a quadratic equation. The most common one, you can try to use precision, otherwise we tend to use the formula. Okay. Because the discriminant is here, then if the discriminant is an ugly number, not a perfect square, then you have no way out to do this method most of the time. Okay. Now again, this is from 2008, Math 125, the point for